Good? All right, okay. Sorry about that, y'all. May have to get a new laptop when I get back. It will not see the external display, so we may flip between these, so there'll be a little delay. That's what we're figuring out here for a portion. We'll get started, though. I'm Taylor Carpenter. This is Denver Williams, and we're here to talk to you about the Cloud Native Network Function Testbed. Introduce the team, some of the people that have been contributing, give a little intro and background on the testbed, why it's here, go through the different parts, and look at how you could recreate what we have, including Workstation Setup and the different portions, including hardware provisioning and the workload infra, Kubernetes OpenStack, as well as examples, and have a little Q&A. So, ideally, with this and following documentation that's published on the CNF Testbed, you can set up a workstation that can run the code that we have, run the examples, provision hardware with Packet, and provision clusters, as well as adding extensions for doing different things on the workload. Is my audio echoing? Maybe it's his mic. Okay, just me. So here's the link to these slides. I think there may be a few updates. We'll upload that. This is on Sketch. So a little bit about us, at least myself in Denver. Vulk Cooperative, we've been around 6 years, and Austin-based software cooperative. We do have folks that are all around the world, including Denver, and we're helping with CNF Testbed and other things. We do run a monthly software meetup as well as a open source axes where we do axe throwing and hang out in Austin. So if you're there, reach out to us. So this particular presentation, the examples that we're showing here, so here's some folks that helped put this together. Michael Peterson wasn't able to make it this time to the conference. Nikolai from Network Service Mesh has helped out a lot, and Lucina, who's out here, also with the Vulk Cooperative. So we have quite a few contributors from different projects, including FDO CSIT, for testing, VPP software, network service mesh folks, people that work on OpenStack, and many other projects. Here's some of the companies that have been involved with the CNF Testbed. So, where did this come from? This is a initiative from CNCF, open source initiative, and the Telecom User Group, which is formed since the CNF Testbed started. We're collaborating with what's coming out of that, specifications, white papers, and it's supposed to provide the capability to explore the different technologies that are coming out and look at how they could work, how you may use them for your networking needs or telco-specific needs potentially. And it's more on the early adopters side of things, but we are working with other groups to try to take ideas and pass them on that may be for brownfield deployments, also taking tooling and best practices that are already out there. This is redeployable on Packet as the primary target, and it supports both their on-demand servers as well as reserved. We've also used custom instances. If you create a Packet account and create an API key, then you can go and clone the repository and be able to reproduce this. We are wanting contributions with pull requests, specifications, updates to existing code, whether that's network functions or the deployment code itself. We, right now, for the workload infrastructure, support Kubernetes, just vanilla Kubernetes and a vanilla OpenStack. I'm not going to really get into OpenStack right now. It's the Chef-based installer, but that's there as well. And we're on Slack and CNF Testbed, and it's not listed, but there's a CNF Testbed dev channel. We're also attend the telecom user group and a lot of the other projects. So this all started back at ONS in 2018 in Los Angeles, looking at an ONAP demo, which is also available on GitHub and has a lot of different use cases. And we were looking at how you could take some of those and maybe either have it running on Kubernetes or take maybe parts of it, and started working through there. And as part of that, we saw that the layers and stuff didn't really fit with breaking it down and making it maybe compatible with different infrastructures. So we started taking the parts out that we could, and mainly the network functions, and starting with those as independent, smaller pieces, and made those work with Vagrant and for the VM side, and then Docker, and then eventually took those pieces and had them working on a vanilla OpenStack and vanilla Kubernetes setup, and started looking at baseline benchmarking, which was in line with some of the stuff FDIC was doing, where they're doing testing to knowing what the hardware is and having a limited set so that you could see as traffic goes through, specifically the layer 2 traffic, and how we would do that with Packet so that we could reproduce and start there. And a lot of that was custom playbooks with Ansible, scripts. Some of that has made it back and forth between FDIC, and we've been able to reproduce some of the same tests that run on that side with the Linux Foundation Labs and what we had on Packet, and then heat templates and some other things to get all this together. Since then, we've been moving towards making it more usable beyond the initial stages, and we've been able to reproduce some of this with different people, including Deutsche Telekom. We've adding new use cases, started looking at network service mesh support, adding different Helm-based deployments of the use cases as we're trying to figure out how do we make this easier for folks to contribute and maintain. And looking back at the goals, so there's all these different technologies that are coming out, and we want to make it possible for people to reuse those different ones. There's projects and initiatives that are trying to build entire platforms that you could use, or a set of examples that are focused on one project. We want to make the test bed easy for you to try out many different things, and keeping that as simple as possible for you to understand what's happening when you're exploring a specific technology within reason. And being able to take those components and build larger pieces. Also, we want to use upstream tooling as much as possible versus building all of our own. So cloud native principles, wherever we can, being that we're keeping this simple. Sometimes that may not be the case, but pointing that out. Version control of configuration, declarative infrastructure. So here's kind of where we are from that first version into the new version. We've pulled more stuff in-band instead of doing more of the playbooks and scripts and other things that we started with. A lot of the initial implementations were stuff like a host-based vSwitch, similar to what you would have with OVS, or a VPP networking on OpenStack, and doing something similar in Kubernetes. And how would we do deployments and testing? So moving to support Helm, kubectl, One of the recent things that we're shifting away from is on the provisioning of your infrastructure. We were using something from a CNCF CI project, the cross-cloud provisioner, and splitting that up to have 2 stages. And for the Kubernetes side, it's based around KubeSpray. It's called K8s Infra, but it's based around KubeSpray. So that's upstream with SIG testing from Kubernetes. And more Kubernetes native implementations for parts that may have been out of band, either custom scripts, Ansible playbooks, or whatever else. And then continuing to add examples. So I was mentioning Network Service Mesh, but also DANM, Multis, the SRV Intel device plugin, and other things like that. We have some other examples that are kind of on the roadmap, like a hybrid use case and other things. One of the other key points was the examples of workload configs. So saying that you want a Kubernetes cluster that has network service mesh support and maybe Multis and some other add-ons that extend the functionality. So here's some just a little bit of a roadmap to see kind of where we're going from here. Keeping adding some new things. We're looking at a 5G demo potentially for Mobile World Congress next year that we're targeting, and working with various projects to make that happen. If we can get some support, we'll like to add a hybrid use case where we have Kubernetes and OpenStack. So you're looking at maybe running an existing workload on OpenStack, and you have a Kubernetes cluster, and you're starting to run, maybe there's some network functions either built inside or a vendor, and you want to connect those and have service change running across. We'd like to get some help on the OpenStack side for maintenance. We've had quite a bit of work on that over the past year, and most of that shifted to Kubernetes. And then we have a lot of other cases. We'll probably be adding some NUMA zone isolation and other stuff with regard to managers that can handle stuff at the CPU level for benchmarking and other reasons. So let's see, an overview of the components and stages. So I talked a little bit about these already, but we've moving towards fully splitting the hardware provisioning from the workload infrastructure, that's Kubernetes, OpenStack, as well as all the pieces that are there. And then we have the examples and use cases, any network functions. Most of these right now are external. We pull them in, so if someone publishes a container, Network Service Mesh has several. We have a few, and we want to be able to support more of those. And then testing tools, NFV Bench, which is OPNFV project, and other tooling. Some of it's internal, some of it's external. Here's a little view of some of the components. This isn't the environment every time. This is just showing a snapshot of what could be running on different nodes. You have VPP running. This is showing if you're running that for doing L2 connections. There's other ways that we could have access to the devices. I mentioned the Intel SRV device plugin. There's other ways that we're going to show, but this shows a little bit of that. The traffic generator with NFV Bench. So Workstation Setup. We're not going to walk through all of this right now, but give you a little bit of an idea. So the main thing is the CNF Testbed repo is, if you clone that, most of the tooling and documentation is right there, and you can run the software that we have based on what's in the repository. So the parts that are outside of that would be if you're going to use Packet for doing your testing, then you'd create a Packet account. You'd need to get an API key created within the Packet account. It has a concept of projects that you can split up. They have certain number of VLANs and other things within those. You can do whatever settings you want to do in the projects. For access to machines, you'd want to create a SSH key and upload that to your account. Specifically if you're going to use a workstation, but also if you're using the workload infrastructure provisioning. But KubeSpray uses, it's based on Ansible playbooks and some other things and uses SSH to connect. So you'll need that in place. But if you have an SSH key, then you get all of this. So most of the workstation tooling to get started is pretty straightforward. If you're already doing Kubernetes development, you probably have this. Docker, kubectl, and that sort of things. You clone the repo. You have your key pair that's local and uploaded into the your packet account. And at that point, you should be able to get going. So we have the steps that were part of the V1, and this is the little bit where it's in progress, probably a couple of weeks out, and what we had and where we're going. So the V1 was all-in-one. If you do a provisioning of a cluster, you're doing the hardware and you're doing the Kubernetes or OpenStack or whatever all in one go, and we're splitting that up. And for that, let's see, a couple of portions on this before we dive into the split. The Ansible piece, there are some parts that are not really possible until potentially Cluster API has support for talking to packet and configuring the network and some other things like that. So for VLAN configuration on packet, they have an API, and we can talk to that, assign VLANs to ports on the network card of a worker node. There's other things that we can do. And so we do have some Ansible code that's still useful at this time for the host, the network, other items. And for that, if you don't have Ansible, don't want to set it up, we do have a container image, CNF deploy tools, and we try to publish that whenever we make changes to it. But you can either build it yourself or download the image and use that to run the different playbooks. And we have other tooling and stuff for doing similar things as far as the deployment. With that, I think I'm going to hand it over to Denver, and he's going to dive in a little bit to the different hardware and workload infra cluster provisioning. Good?
Good. All right. Hey, everyone. I'm Denver, and I've been working on the CNF Testbed initiative since it first started, and most of my background and work on the project has been around the Kubernetes side, the OpenStack side, and the automation tooling around those projects. So I'm going to dive into how the hardware and cluster provisioning works on the CNF Testbed. So as Taylor mentioned before, we were originally using an approach called cross-cloud, and what that was doing is it was provisioning the hardware and Kubernetes at the same time in one swoop, and we've been wanting to split that out so we have two composable pieces, and that allows us to do things like configure underlying network and cleaner stages. So the first stage that we now have is hardware provisioning. So an overview of this stage is we have this repository called Infra Provisioning, and this is actually a repository that's used upstream at CNCF project as well. And what this consists of is some generic Terraform code that's composable and reusable. And this is what's used to request the packet servers. And it has the ability to use both reserve servers and on-demand servers there. And then also at this stage, we'll use Ansible to provision any hardware level configurations. So maybe there needs to be some particular changes to hardware NICs, or when we're at Packet, they provide APIs to make changes to the underlying network, like provision a VLAN on a particular switch. So we also make some infrastructure level changes there. And then if you're wanting to use this tool from the CNF Testbed to provision hardware, then the steps to do that are, if you go to the CNF Testbed repo, there's a tools directory, and there's an environment file in there, and that's where you can configure things like the instance type, the deploy name. And then, as Taylor mentioned before, you can get a packet project ID and key. So once you have these, you can set these environment variables. And then once those are set, you're all set to run the provisioning. So from the tools directory, you can run the hardware provisioning script, and that will go through and provision a set of packet servers based on the configuration you had. And it will also output a file under the tools directory called nodes.env. And what this is it's an inventory file, a collection of the nodes that are provisioned, and then this can be then given to a tool like KubeSpray or some other provisioning device that will then take those servers and provision a workload infrastructure. So stage 2, this is where the second stage comes in, and we provision a cluster, whether it be OpenStack or Kubernetes. So the other things that happen at this stage are complementary services. So there's additional tooling and infrastructure just off to the side of Kubernetes and OpenStack, like NSM, Danum, Voltus, or installing a BPPV switch directly. And then we can also do configuration at this layer, so maybe VLANs, VIFs, or SRV devices. And the component here that does the Kubernetes provisioning is called KADES Infra. And what this is it's a wrapper around KubeSpray, because whilst KubeSpray is fairly straightforward to use, when you're wanting to use particular versions, it can get a little annoying, and there's lots of configuration options. So we decided to create a simple declarative wrapper around it, which provides a CLI interface and integrates with the testbed as well. And then also, as mentioned before, we can use Ansible for out-of-bound host configuration for networking, or additional configuration services at the Kubernetes level. So these are things like Helm charts for network service mesh or Danum. And if you want to use this tool to provision a Kubernetes cluster, then from the tools directory, you'll be able to run KADES infra generate config and pass it some configuration flags. So the first one we've got here is the release type. So this can be set to head, which will then go fetch whatever the current head version of Kubernetes is and deploy that version. Or it can be set to stable, which will take whatever the current stable version of Kubernetes is. And then there's this next setting here is host file, and this is the file that was outputted to tools before in the hardware provisioning stage. And then the -o flag is to output this configuration to a directory. And once you've got this configuration, it specifies what nodes should be provisioned, what version of Kubernetes is being used, and you can run the KADES provision and point to that config file. And what that will do is it will start the KubeSpray repository, and it'll then execute the Ansible code to run and provision the nodes. So use cases examples, I'm going to pass this off to Taylor, and he's going to go over those.
Sure. Before we go on to the use cases, does anyone have any questions about the prior stages? Hardware provisioning or the KADES? I guess one thing I can point out is this is one way to do like the generation. We support passing IPs, so if you didn't use the hardware provisioner but you already had a machine set up, you can specify the worker nodes. We have flags for that, so you can specify the worker nodes and the master nodes, and it'll generate the needed configuration that CubeSpray wants.
So it's a multi-stage process, right? Like what you explained. The first step is the hardware provisioning, and then you go in and do the like Kubernetes or OpenStack provisioning. There is no chaining between those two, or?
So the question is this a multi-stage provisioning, and is there any where we have the hardware and the Kubernetes or OpenStack separated, and is there any chaining? Is the question?
Like a workflow, right? Like
Yes.
you define a workflow that okay, you do hardware and then you do like Kubernetes on that hardware. So is it like a two-step process or a single like?
So we're explaining the components that can be run independently as two separate stages. In the past, we had one script for doing the deploy before you would run any use cases, and that would be fine to essentially run one and it feeds the other. This specifically is so that we can run it and then feed that, versus if someone said, I already have my machines and I just want to get Kubernetes on those. We're using CubeSpray. One reason we use CubeSpray is because it supports doing a reset. So if you had a set of machines that you want to bring back to the base state with just the OS, then CubeSpray supports that, and that's something we're going to be having in here to run again and again. But if you wanted to do more like a workflow where it's doing all of it once, that would be something pretty easy to chain based on what we've done.
The other question I had was like, we are building this infrastructure for CNF, right? Different CNF can come with different kind of requirements from hardware or from like your infrastructure, like Kubernetes or OpenStack, right? So how are you handling that? Like, okay.
I think you're good. So the first part, I'll just repeat real quick, that different network functions and functionality could require different hardware, and how are we dealing with other hardware?
Like they will have like different kind, like hardware requirement. Like as you know, like network functions can be very, like their requirement can be very hardware specific. So how are you handling that? Like because it's a, like the way I understand it, it's like common infrastructure you are building, and you will be bringing in any kind of network function, right? That's the general purpose for this, right? So.
Sure. So there isn't anything right now that's going to be generic enough to say it's generic and it supports everything specifically. So we're adding support as we go. And right now, the example would be on Packet, they have machines that have Mellanox network cards, and then they have machines that have Intel. And then the setup and configuration of those, specifically if you're going to have accelerated access, is different. So we've built support originally with all the Ansible playbooks and stuff like that. We've moved as much of that as possible out, so it's a slimmer layer, and trying to use software that can support both. DPDK is, they have a focus on trying to be able to do acceleration for different devices. And then if you look at stuff like a project like Network Service Mesh, the idea would be from there, and it's an example of an idea, that you would have a node that's saying, here's what I have to offer, and then a service saying, I would like this type of accelerated access, and ideally those come together. Right now, those pieces, I would say, are where you're going to have stuff that's going to go out of band. So we have examples that we're working on, say with the Intel device plugin with Multis, and that's going to give you some of that, but it's not covering all the different hardware. So a generic solution, I would say, is not fully there yet, but we're trying out the different pieces to kind of move towards that. And the other part would be separating, say, as much as possible of a use case or at least the components that you can, from the parts that know about accelerated access. So ideally, you can build most of, say, a service chain, and you may get up to one portion that knows more about the specific devices. That's the approach we're taking right now. Any other questions? Do you mind repeating? Go ahead.
What kind of process do we need to go through to get access and maybe some of the machine time on those specific machines with specific NIC that we might need?
Okay, so I guess working a little bit backwards, the first part would be everything is on packet and the machine information is publicly available. And we're trying to make sure that if we're, whatever type of test, that we're running the results from those, that we specify the instance type and the hardware and stuff that was used. So ideally, if you were going somewhere else, you could also use that. So there's been, for instance, testing outside of packet that used Intel NICs that are compatible with the Intel X710s that we've been testing with on packet. And we're using a specific Mellanox, so if you know that, you should be able to test anywhere. And then more specifically for getting access, so a little bit further on in the slides, there's a packet.com/CNF. You could get access to credit and go create your own account on Packet. There's also the CNCF Community Lab, Infrastructure Lab, and that's also run on Packet. So if you go through CNCF, particularly with open source projects, then you can get access that way. And the CNF Testbed right now, the main maintenance that's happening is ensuring that it would run on Packet. So whether you're in the project specifically, let's say the CNF Testbed account or not, shouldn't matter. We're not using machines that are not publicly available, with the caveat that there's a new instance called the N2, as in like Network 2, extra large. That one has Intel quad port NICs. We helped get Packet to add this. We had initial access probably 6 to 8 months before it was publicly available. That one is now publicly available. So we may have some type of early access, but everything that we're doing, we're trying to say, okay, this looks good, please get a public version of this, and you should be able to find it and use it. If you have a Packet account, you can have access to the machines. And if you want to get access to the machines we're using, then you can join us on Slack and help contribute, and we'd be happy to give you direct access. Any other questions? All right. How are we on time? 5:59. Okay, so use cases and examples. So what's changed? This is where if I was on my laptop, I would click some of these links and show you, but I'm afraid to do that on an iPad, so I'm not going to. It's all right. So the tooling has primarily been we've iterated on what we have. So I mentioned the CNF Testbed tool image, and that has a lot of different pieces in it, including the Ansible portions and other upstream support from different tools. So it kind of helps you do many different things. One of the big changes that's still in process has been in a folder that you can find in the repo called the comparison folder. And this is where we had all of the Ansible playbooks still live there. They haven't been moved over. But the other thing would be the actual test cases and examples, where a lot of these were custom scripts. Some of them still work perfectly fine, but we're not maintaining those. We've mainly been rewriting these in the new structure, and that's under this examples folder if you're looking at the top level. And that area is the main portion where we're focused on, and that's where it has, if you look at that in the repository, there's 3 main areas. There's the network functions, which is actually empty because so far everything is either upstream with other projects and we pull in the published images, or we have an image that's in the old comparison directory and just hasn't moved over. The 2 that we're mainly focused on is the workload infra and the examples of use cases for different things. And the idea here is to focus on supporting multiple implementations that you can compose into larger, more complex use cases. So it'd be great to see Multis with Network Service Mesh and Network Service Mesh with DANM and other things like that. We want more in-band support. We talked about that earlier. Along with upstream tooling, we're trying to also use upstream Helm charts if a project has it. So as much as possible, Network Service Mesh is now starting to publish the Helm charts as their releases are moving forward. And any type of manifest for installers, we'd like to use the upstream, and if we want to modify something similar to what we've done with CubeSpray, most of these things you can override pieces, where we wrap an additional component and extend what's there. And that goes along with minimal wrapper so that we have some type of consistency between examples and use cases where we can, while not totally rewriting or changing what upstream projects and initiatives are already doing. So this first example, we have 3 here that we're showing. This one is based on a benchmarking test case that we have. We've been working on for quite a while. FDA CSITs run this, and we've had folks from that team contribute a lot on the playbooks and the original stuff, doing a lot of tuning of the network functions, the vSwitch, other pieces. So what we've wanted to do is take that and make it usable with the new structure. So this particular one, it has a vSwitch that's based on VPP, and you can run this either in a privileged container or you can run it on the host directly. And you have some number of, the network function that we're looking here is very simple. It's just an IP forwarder, IPv4 or IPv6 packets, and those go through the vSwitch into the first network function, pass through and loop back to the next network function, making a chain, and that's the idea with the snake. And you could have different depths. This particular example, if you go there, this is using 3 chains with 2 network function in each chain. And this is based on the number of, this particular set is based on the number of cores and isolation that we want to do on the particular packet machine that we're testing on, which you could again do different numbers. So this one is Helm-based. For the test, you would have some packet generator machine. We have Ansible code and other pieces for setting up a machine that can run in a fee-bench and generate the traffic that's going to point at the worker node that you're going to be testing. There's specific things, this ties back into the hardware question, where you need to know the configuration, like PCI devices, or you may need to know PCI devices, you may need to know MAC addresses, other things potentially. for some of these tests, on this one, we're using NFV bench that is using MAC addresses for how it's sending traffic. And this just happens to be the configuration that we had before, and we're pulling it over. There's different ways of using that, but that's set up here. We have extracted it from being static within the network functions and other parts. You can pass them as values. This will probably be pulled further out. Ideally, where maybe you're able to talk to the node and find some of this out, pass it in, or test information. And then otherwise, when you're wanting to run this, you have your packet generator machine, and we're just have a little wrapper script around this, but it's essentially, if you run NFV bench, you have a configuration file that specifies the size of packets, the length of time, and a bunch of other things that you're going to pass in. And when you run this script, it's going to pass all that information. And we have a NFV bench container that has a lot of the tooling, so you don't have to worry about any of the setup. You run that, it's going to send the traffic against there, and you end up with some results. With that, we're going to see if we can run this right now, if we can switch over to this other machine and show you this particular example, how it would run. We're not going to deploy everything, because that would take more time to set up the machines, but at least running the test. Hey, it looks like you have a screen over there. I think you're good. Oh, it's back.
All right, we're good.
Let's see.
All right, so we're starting from the CNF Testbed repo, and from here, assuming that you've already run the workload provisioning stage, got up a Kubernetes cluster, and it would have outputted a Kubernetes configuration file. So if you set that, we should now have a Kubernetes cluster up, nodes available, and no pods. So I'm going to start with the snake case that Taylor just explained. So first step is we actually need to make sure we've got a vSwitch up and running on the host. So we start that, and then the next step is to install it. So under the current directory of the CNF Testbed, you have examples, use cases, then you have the 3C, 2N, CSC. So this is that use case, and the only modification that needs to happen is we need to update the Helm chart values under the CSC values file. And what these are the MAC addresses for the packet generator. And the packet generator is a server that we have the code for setting it up, and it's the documentation there, but it's already set up for this use case. And you want to enter the MAC addresses of that server. And once that's up and running, you can do a Helm install of the use case. And we want to wait for now is for the use case to be up and running, and it looks like it is. So the last step is to test this. So we want to switch to the packet generator server, and we have a run test.shell. And what this is a wrapper around NFV bench, and it will go and send data to the CNFs we just deployed, and doing it in a snake case, so it's going into each CNF and then down to the host vSwitch and back out. And then this does take a little while to go through, but once this finishes, we'll get an output of how quick the data was, how many packets did we lose.
You got another minute or something there? We're planning on working with FDIO CSIT and a couple other folks on picking some of the use cases like this one and then running tests on those sets on a regular basis and publishing the results along with the machine information and other stuff. That happens constantly in the Linux Foundation Labs, specifically around VPP. And we'd like to do that here. Similarly, we'll probably end up with some test results for functional use cases.
All right, so those are the test results. So we have NDR results, and that goes over how many packets per second, latency, and the drop rates.
On this, some of this, the benchmarking, we put limits because we're on packet, which has, this isn't going to be like your own custom lab. They have 10 gig NICs throughout any machine that you have access, and they're top of rack switches. Oh, that's even easier.
Yeah, so
All right.
you want to go through the next use case, and then
Sure.
I can deploy it.
How are we doing on time? 30 minutes? All right. Let's see. Well, does anyone have any questions on that particular example before we move on? Oh, go ahead.
Hello. Since you're chaining stuff, like, are you using, you mentioned like pooler before, are you using CPU pinning and?
This one is using pinning, but it's all custom. Like, we can pass it as Helm values, and we know that based on the packet machines that we're on. We do want to use, we're going to add support for CPU pooler. That's on the roadmap, and other ones. But right now it's manual pinning, essentially.
At the Kubernetes level, or with some other kind of wrapper to specifically?
So these IP forwarders, they're essentially VPP and in an image, and we are passing the available cores that those can see whenever those are spun up. Whenever we're using, so I'm showing the snake case, so the vSwitch actually has privileged access, which we can say what cores it can see or not. But we also have what we're not showing is a pipeline use case where they connect via MIF, and it would be similar. So we're passing that information so that the image has it, and here's the cores available to it. And what we would like to do is once we've added the CPU pooler as a infra level, can you get it back down? I think I showed it. Once we add CPU pooler as a infra level available, then we want to add use cases where we'll probably update this one and have an implementation that uses that for doing the core isolation. Thanks. Example one, I think. So any other questions on example one? All right. Okay. So example two, which all of these have, by the way, GitHub links. So if you get on the slides, or you can go right to GitHub, and they're all under, the ones that we're talking about are under the new structure, under the examples. Example two is a very minimal example. I wouldn't call it a use case. This is more of how to use something. So it has two pieces, and that's why it's split here. There's actually two links. So one of them is the workload infra setup, and this is where we're adding the SRV device plugin and to Kubernetes. And then after that, now you have access to be able to add support into a pod. So this example is saying once you have that in the workload infra, then do you have access, can you see it in a pod? So it's a very simple way of showing that that works. But again, this is try to help people that are exploring these technologies. What we don't have on the slides here, but we do have, if you go in the examples directory, is an example showing Multus plus this device plugin. So the simple device plugin example, and then we have another example, Multus plus the device plugin, that actually shows how that would work for querying and accessing. And that's where we'd like to extend on, say, maybe the last example for accessing the device using Multus and the device plugin. But the idea here is we have one that's kind of on the benchmarking side, and then we have exploratory examples of here's how these different projects work, and then here's how they work in larger examples. So this one's simple with kubectl, and you have the workload infra portion, and that's about it. At that point, you're good to go. So what's next? This is a little bit of what I was saying. So we're going to take the simple one, and we have the Multus already, and we're picking out a couple of different use cases. Probably the next one that I'm showing maybe where we want to do this, but using Multus as an example of getting access to the hardware and then passing it to a particular network function. So with that, here's the third example, which is also available in that same folder. This one, don't really know what we want to call the name, but the idea here is multiple paths for the clients. This could be different service chains. You could have it segmented. But what we're showing is two clients that are connecting with a packet filter. I think this might be a little bit better. But we have a packet filter, two gateways, and we're showing different access from the clients. And we're also showing, this is a network service mesh example. So we have, you're seeing a kernel interface as well as MIMIF interface. For this particular example, it uses, with network service mesh, this allows us to connect, provide all the connections between both the client. Is that going to go? It's still loading.
There we go.
All right. So, so the network service mesh is allowing us to describe the connections between these. So some of the other ones, we're creating the connections by specifying the pods, the containers that we're going to be running, and then manually creating those connections by passing the interfaces, or it's going to connect to the vSwitch or various things. With network service mesh, we're actually using it to provide the connections between the different services. So in this one, we have a packet filter that we show how we can drop connectivity going out if it's requesting access to something, a gateway that it shouldn't be going through. And this is also showing access outside of a Kubernetes cluster. And the idea with this one is to show where we could go if say, this could build onto that hybrid use case I mentioned earlier, where the external access may end up being a VXLAN connection to OpenStack, or maybe you have multiple clusters. There could be different things. But the idea is you're going to exit the Kubernetes cluster and you're not using the regular built-in network path that Kubernetes gives you. We're going to provide a different network path. Another way of looking at this would be maybe you have a segmentation of traffic where one org can go down one service chain, but they should be split and segmented out. This isn't a physical separation. This isn't software, but there's different things that we can build off of this. And this external gateway is also showing us physical access from the network function. So how do we do that? And so this is a little bit about what we talked about. We have Helm, network service mesh, and the external endpoint. This could be anything. Right now it's a simple Nginx server or whatever you want, but it could also be another cluster. You could look at other things. And this has the workload infra. Right now it's the network service mesh and Kubernetes. In the future it may be network service mesh, Multis, the device plug-in. We could add other things on there. The CPU puller, there's many different things that you could add. This is what we have right now. And again, you can pass in different things to Helm for setting access to devices and other pieces. And in this one, we're not doing a benchmarking, so we're not using NFV bench, but that would be fine. These are, you can mix and match the different pieces. This is simply doing a connectivity, like a ping check between the two clients and that external machines. And I think we can go ahead and try this one.
Yep.
All right.
All right, so before we run this use case, we do have to do a little bit of cleanup to get rid of the last one we just did. So Helm delete purge CSC will flush out the snake case we just ran. And we also need to disable the VBPV switch, because for this use case we aren't using it, we're using NSM. So once that's deleted, we can deploy NSM, which is acting as the data plane in this use case and is responsible for chaining all the CNFs. And under the current directory, the testbed, it's under the examples, workload infra, and NSM. So we can install that, and that's not good, but that should be easily fixable. All right, I think we're good now. All right, so that will start deploying NSM. So we should be able to do get pods, and we see NSM manager already up. And we should start seeing other things starting to come up. Yep. So we need to wait for NSM to come up, so this normally takes a couple of, maybe 30 seconds or so, so shouldn't be too long.
So one of the things that we're looking at doing is trying to make the workload infra where you can do some of the chaining that we were talking about for like hardware and other pieces, but the workload infra specifically. If we use Helm and for building these, and ideally you can do dependencies, and you could specify similar like a blueprint of what you want your infra to look like, and that can be pretty minimal, and then pull in all the pieces. We've started with some of those examples. We would like to have feedback from folks that are actually trying to build different use cases and examples and maybe sets that would be interesting, where you have a matrix of the different components, and we can add those in.
All right, so we have NSM up and running now, so the last stage for this is to deploy the use case. So this use case is under the NSMcon XDPF directory, and this one doesn't require any additional configuration. It's all enclosed within the Helm configuration itself. So we can run Helm install, and once again, we have this wonderful problem, but at least it's easy to fix. And teammate is playing games with me. All right, we're good to go. So we can run helm install and install the use case, and this use case does take about a minute, 2 minutes to install because it's installing a lot of containers. I think there's probably about 6 pods all up in this use case.
So while we're waiting on this one to come up, and then we'll take a look at how the pods look and everything. Does anyone have any questions on example 3? Or example 2? Go ahead.
Hi. Not specific to example 3, but just wanted to know what kind of CNFs you've used for your tests so far. I mean, there could be a variety of CNFs that is available already. One more thing is, I come from a telecom world, and I'm trying to come up with a 5G use case with Kubernetes and try to deploy it. And I use HCNFE for deployments. So I want to know, have you tried using a VPC as a CNF for your testbed? And have you tried any 5G? And I heard you saying that you're going to use, you want to demo something for Mobile World Congress, I believe. So what exactly you're trying to come up with? So it's all related to the CNFs. So just want to know about that.
All right. Well, most of them that I'll say the 2 main ones that we're using are VPP-based, somewhat generic container that we can use. It's an image that we can configure for multiple things like the IP forwarder, and you can make it do different things. The vSwitch is based on that because you can set up VPP, and that makes things pretty easy. We do have some images in there that were from the ONAP demo that use some other software, but they're all pretty minimal on the subset of software. And the other one that we are using, which is actually being used in this as well, is NSM calls it Universal CNF. It's an example, and it's also has part of it's based on VPP, but it has some other stuff in there like the NSM agent, and VPP agent, and other pieces for doing various things. So these are kind of generic examples that can be configured to emulate maybe a network function that you'd be using and different functionality that you want to see. We're interested in testing others. Most of the problem's been around open source, getting something. If there was an example, we don't particularly need it added, but if there's an example that can use something that's available like a published image, happy to do that, especially if the capabilities are there. But those are the main ones, and we'll probably be adding some others that won't use VPP, specifically like some firewalling and some stuff that we're looking that's in the ONAP demo that I was mentioning. For the 5G, we're looking at several different things, but the open air interface project was used, in fact, in the keynote 5G demo and the proof of concept that was shown on the keynote the other day, and we were looking at using that. So that's one of the components, and there's several other potential examples. And what we really are looking at is what's available that we can make readily reusable. So there's definitely going to be devices out there that we're not going to have software access to, or if we get it, it's going to be working with someone. So if someone contributes it, we're happy to have it, happy to have the specification. The main focus for everyone that's been involved, though, is does everyone have open access to it? So, did that answer your question? Go ahead. Okay.
We're about ready.
just adding on to that question. So are you also talking to, you talked about open source. Are you also talking to like CNF vendors out there? Because this is a like CNF Testbed by CNCF, right? So
Yeah.
are you involving any like major vendors to bring their like CNF to on this test bench?
So not on the network functions themselves, but adding, I guess, the functionality for running them. I mean, we are talking with them. Getting a vendor to contribute something there, that's, I think, something that we'll look at getting to. How are we going to do that? And I think some of the earlier slides was talking about it, where if we can make it where we can deploy the platform and anyone can deploy it, then ideally a vendor or whoever could create their own account and deploy that, set it up, and then deploy the software that they want without, say, handing it over to us or anything else. And so figuring out the interfaces and those gaps would be probably the first thing. And we are in contact with the vendors, so I think once we get the infrastructure matching what's needs, then it'll be, okay, they're testing it and what's missing to actually test those type of things. And operators as well, so we have folks from different telecoms.
See, if you take an example like a VPC CNF, right? A complex CNF which involves multiple VMs within it, which is, I mean, I come from an OpenStack world where I can actually deploy a complex VNF and tie them into a network service. And it has multiple VMs, maybe high available ones. For me, the challenge is like with Kubernetes and a lot of encapsulation, there is like external networks that needs to be connected for these CNFs per se. And then there is like internally all these, the VMs within this CNF, probably you need to set the traffic for that as well, right? So there's like multiple levels of networking involved. And what kind of plugins you suggest from Kubernetes world for us, like for people from telecom world who wants to use Kubernetes for that? I mean, have you had experience using it? I saw some presentations already like CNI and Multis and all. So what's the best plugin that we should probably look out for and then set it up in our deployments and try it out, That's the question.
So I'll try to approach that from two parts. There's a lot of CNI plugins, just like there's a ton of different add-ons for the functionality. And one of them would be, there's an OVS CNI plugin. And I'm sure that you could find some set of extensions for functionality like the CNI plugins for Kubernetes that would allow you to, I don't want to exactly say emulate, but recreate maybe something that's similar to what you have in OpenStack. I don't think it's going to be an exact match, but you can get close. And the more complex, maybe the less close. But this service chaining benchmark example that we were looking at, that was literally one that we took originally from using VMs, and that was, you could do it with OVS or whatever, but we specifically were using VPP networking in OpenStack. And on a worker node in Kubernetes, there's no real reason to have a vSwitch in place for that particular setup, because you could, instead of going through a vSwitch, you can chain them directly with MemIF interfaces, and it's going to be much higher speed. If you're using something like network service mesh, then you can create and add connections and that sort of thing. So it's not something you would want to recreate. You'd kind of want to rethink it. But if you said, we need to move over, or we're trying to support some of this, I think there's examples where you can get some of that functionality. And then the other part would be when you have time and where Where it's valuable to see, we would like to improve on a particular portion versus, from my point of view, the entire platform. I'm not saying recreate everything, but particular portions, you should look at the principles behind what cloud native means and process, and that would be similar to what, say, Network Service Mesh is doing and what I'm saying with like the MIF connections. You go, what do we actually want to do when we create these chains? And there may be a totally different way to do that, and you can get other benefits. And there's just many other things where the ideas around how you're going to build the services, which are sets of network functionality, like larger applications, which this, with regard to these, would be like a cloud native application that happens to be focused on networking, and that's going to be a set of many different things. So when it talks about microservices and other things, it's not that you want to check mark all the buzzwords, that you want to use these specific technologies. The idea is if we can simplify these services and let the application do what it does best, but to let the infrastructure do what it knows, then you're going to be better off building these things. And most of that's around the principles and stuff. It didn't come from Kubernetes. Kubernetes is an implementation. So, any other questions?
I guess in the examples that you've given, like if you're using, for example, like CPU pinning and chaining, all these things, when you run those benchmarks, does the bottleneck start becoming on packet like the network throughput or CPU usage, or like kind of like what's the performance when you're kind of running these things?
Well, most of the benchmarking is, we've kept it minimal on the examples, so that if you're benchmarking something that's also doing like a DHCP request and other things, those are going to be your bottlenecks immediately. So these examples are very minimal with IP forwarding and stuff. And for network bandwidth, you can limit the number of packets and other things. If you're saying, what is the maximum throughput for a network function, then that's not something that, for a particular implementation, that's not something you're going to do if it's needing to travel outside of the worker node in a network where you have limited bandwidth. So these particular examples, we can max out the bandwidth on packet. So we limit the traffic output, which you can, this is NFV benches set for doing this. How are you going to do it so that you can get results that are meaningful? And we're just not testing that. But Linux Foundation, they have labs with, they have 40 gig, 50 gig, 100 gig NICs. I know that they're testing other things, so you could do that as well. We just don't have access to it in packet.
I mean, initially, when we did our bandwidth testing on packet.net, I think we actually dropped one of their core switches.
Yeah. We could finish this example, I guess, if it's ready. I think it's been ready.
Yeah, it's good.
Go ahead.
So here, where we left it, the Helm install, it's finished, and there should be some new resources there, packet filtering, and then a few config maps. So if we jump over to here and look at pods, we can see that there's a gateway left and right that were deployed, as well as a packet filter, a sample client. So we're ready to run the tests now. So if we switch to this directory where we deployed it from, there is a KubeCon check connectivity script, and what this will do is act as a client, and it's going to ping through each of the CNFs that were deployed, so going through the packet filtering gateway and then redirecting to the endpoint based on which client's requesting. And normally takes about 30 seconds to jump through these.
So one thing I think that we're going to want to add beyond this, a lot of this is like developer-oriented and console, of course. We're going to have the results that I mentioned earlier, benchmark results, as well as like test functionality. If folks have particular tools for like visualizing the chains and stuff, specifically that are more minimal. So I know that you have tools like ONAP and other things for creating and building the visualization of how these look. What I'm talking about more is showing these type of examples of what's running and the type of traffic. But if there's things that you like and would like you recommend, then please let us know. We're looking at some different ones, but be open on that or any other pieces.
All right, so the test is finished, so you can see the ping results. It went through each of the endpoint and was successful. So bring back up the slides here.
All right. So that's really it. Here's how you can connect with us. So the CNF Testbed repo, and here's our Twitter. And we're also on Slack, on the CNCF Slack, CNF Testbed, as well as CNF Testbed Dev. We're on the twice monthly telecom user group calls. We've been engaged with the LFN CNTT initiative, so you'll see us around. And I know we've been doing Q&A back and forth, trying to allow you to have questions as it's going, but if you have anything else, then I think we have a little bit of time. 2 minutes. We have 2 minutes.
Just got a question when I was looking at the IP address. Like when you run the helm command, right? Did you provided the gateway for all the pods, or it's like NSM is taking care of internally?
There's a values file in the Helm chart which has defaults for most of that, but it can be overridden with different IP.
Okay, so but like there is a use case that we can provide the gateway. So is it possible?
You can provide what?
Like the gateway for the, like let's just say like all the pods are in like one subnet, right? Mm. But if we want to provide our own when we create like on the YAML, is it possible?
So you could replace the different components. I mean, it's a pretty simple YAML manifest describing the different pieces that are part of that example and the chains.
Okay.
Specifies the upstream image and that sort of thing.
So when they gave a keynote around the 5G demo yesterday morning, there was a challenge that was mentioned around the CNF descriptors, specifying various properties for each of these, ports or anything that is related to the CNF, right? So, and my question is around the bitrate requirements. If I have to pass from a user perspective, I want to set the bitrate for the interfaces that are configured with these CNFs. Have you tried that doing for your testbed? I mean, modifying the bitrate and checking the traffic and seeing. I mean, can we manage the CNFs in a way based on the user's policies through the descriptors, CNF descriptors?
So, are you asking being able to add or remove interfaces based on traffic?
More about the properties of that interfaces. Like can I change the bandwidth?
Okay. That's not something supported in any of these examples, but I don't see a problem with that. It sounds like, in my mind, you would have something that can analyze the traffic, of course, and then the network function should provide that functionality. Yeah. The ones that we're using, I could definitely see an example created with that. So VPP has a capability of restricting, and there would be different ways of doing this. You could have one gateway, or you may have multiple services, and so you say each one of those services has only a specific amount of bandwidth, then that would definitely be possible. All right, I think we're out of time, but if y'all have any other questions, we'll be around for a bit. And otherwise, catch us online, Slack, and thank you so much.